Welcome. In this video we're going to learn a recursive strategy called binary search, which is very useful for finding elements in a list that is already been sorted into ascending order. So the general problem is that we have a list and we want to find a value within that list. We could always just sequentially go see if it's 2, then 7, then 20, then 25, and see if any of these numbers matches our result. But that's slow because in the worst case you have to traverse the whole list to find a result. Let's come up with a new strategy. In this case we call it binary or dichotomic because we split the list in two every time we go searching for the number. So at the beginning we start focusing on the whole list and we say, okay, if the number is here, it must be in the list. Then we locate the midpoint, in this case 38. And we locate that by using the indices ini and n, which is the beginning and the end of the list. In this case it would be 0 and 8. And we divide that sum by 2 to obtain the halfway index. Then we access this value and check whether it's equal to the value we're looking for, smaller than that, or greater than that. And in any case, we go looking for the half that could contain that number. So for example, if we were looking for number 9, we know that it's on the left-hand side of 38. But if we were looking for number 75, we know it's on the right-hand side. According to each, then we split the list in two by assigning the end or the ini index to a new value and then focusing on just a sublist of this list. If we repeat this problem a few times, so for example, if we were looking for 75, we would go to the midpoint, which would be 70, and would say, okay, 70 should be on the right-hand side of 75 should be on the right-hand side of 70, so we look here, and then we check 99, and we see, oh, 75 should be to the left of 99. And now we know that this was the beginning, and it's now the end, so we haven't found it. Another example, for example, if we were to look for number 20, we would start again at the middle and see that 20 is smaller than 38, so we'd go look for these four elements on the left, and then we'd focus on the half point, which would be 7, and we'd say, oh, 20 is greater than 7, so we would set our begin point at 20 and our end point at 25. The midpoint would be 20, and then we would say, oh, we found 20, and return the position where we found it. So the general case in which we implemented would look something like this. First, we need a user-facing method containing the list argument and the element we want to search for in the list. This method is very simple. It just has the initial call to the recursive problem, in which we say, okay, we start looking at 0 and we stop the search at the last element. And then if we go to the recursive implementation, then we can see that the base case is whenever the begin and end pointers are crossed, so the begin index is greater than the end one, and in that case we haven't found anything and we return -1. And in the general case, we apply the binary search strategy and split the list in two as necessary. So first we compute the halfway point by using ini plus end divided by 2. Note how we are using the integer division because we want indices, and indices are natural numbers. Then we access the value on the halfway point in the list and check whether it's equal to the value we're looking for. If it is, then great, we've done it. We return the index and we're done. Otherwise, we want to check if it's greater or smaller than. In the case that is greater, we'll go look on the left-hand side, so we'll say that the end is the midway point -1. And otherwise, we'd say that the beginning is the midway point +1. It's very important to include this +1 and -1, otherwise you will keep analyzing the midpoint unnecessarily. And that is all. I'll see you on the next video.